In earlier lecture, we have seen the different concept related to OOP, and we have seen the procedural oriented language and the OOP language difference also, and why this OOP language came into existence, right? So, if we have seen the what is the concept of object and what is the example for the object we have created in that, right? So here class example we have seen class and the name of the object class is example. Then we have declare some variables of different types, and then we are calling that the object from the main class main method. Okay, so this is what how we can write down the uh, class and the object. Okay, so similarly the classes concept is there. In that class concept, classes, a class in C++ is the building block that leads to the object oriented programming. Concept that one by one we are looking is first we have seen the almost every languages type of languages, then we have seen the type of languages of procedural oriented and the difference of the OOP languages. So after that we come to the different types of characteristic of OOP language. In that we have seen the first objects, then we are seeing the classes. A class in C++ is the building block that leads to the object oriented programming. It is a user defined data type like structure. This concept is in C language. Like structure, the class is also user defined data type which holds its own data members and the member functions. What it holds? It holds the data members and member functions which can be accessed and used by creating an instance of that class. What does it mean? That whatever the class consists of the data members as well as the member functions, this can be accessed only by the object of that class. What is an instance of that class? It is a variable or object of that class. Okay, so we can say that a C++ class for C++ class is like a blueprint for an object. Okay, so it's a class is a blueprint for an object. Okay, so this is what the class for class we can say classes is having the structure like class keywords and followed with the class
Hello,
name.
hello, ma'am. Hello.
It takes time. Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay, see, the class structure is like class keyword followed with the class name. Then the access specifier are there. Access specifier can be private, can be public, or protected. So all this detail we are going to learn one by one when we start with the C++ language itself. Okay, right now the structure is access specifier colon, then the data members are declared followed with the semicolon. Variables are to be used here with the accordingly their data type. So the collection of different data types can be present here along with the access specifier. Okay, so then the member functions are written for accessing this the data members. Okay, so member functions are written for the handling or for manipulation of this data members of the class. And if we don't write the data functions or member functions, we cannot handle this private variables or data members of the class. Okay, so structure is class definition for this along with followed with the semicolon. So semicolon is important in this case. So class names ends with a semicolon here, right? So whenever you are writing a class and you are writing the data members and member functions, you can then followed with the semicolon. Likewise, the data members include members that are declared with any of the fundamental types as well as other types, including the pointers, reference, arrays types also, bit fields and the user defined types also. Okay, so all type of data members we can write in the class. Then the data members, which is example I have put here, hash include IO stream, that is our IO stream related input output related, our class is there. We can access the cout scene here related to IO stream. So using that is the first statement. Then using namespace standard, as earlierly said, we require this for following the namespace. Then the class student, student is having the name of the class and followed with the private members and the public, that is the data member data functions which can access the private members, that is the integer id and the character name. These are called as the data members, and followed with the in public, that is the scope here. So access specifier for the method is public, and we are writing the data members inside the scope of private. Okay, so nobody can access this other classes. Then we are having void get data and void display. These are the methods. Okay, so these methods are called as member functions, and the data are called as data members. Okay, these are the two things which we are declaring here, the data members and the member functions. Right. So one can write the definition as well as here definition of the member function inside the class, and one can write it outside the class. Okay, one can write inside the class and outside. Here void get data I have only declare you, but I have not written the definition. And another is void display. This is a function which I have writing the definition as well here. So see out the id and see out the name here for the same time inside the class. After that class is ended with the semicolon. Okay, then I am writing the int main function followed with the object declaration. The object is what? The class is student, so followed with the student and the name of the object. Okay, this is what the data members and the member functions comprises of the class. Then next is the methods, which are the, we can, how we can write the methods or the functions either inside the class definition or outside the class definition. These are the only two ways how we can write the our methods. Okay, either inside or outside. So class example, again I am putting here public, in that I am writing the void add function and the this definition itself inside the class example, followed with this ending of the class, that is semicolon. So I am now writing the example, that is a class name, followed with the object of that example class. Then I am calling the function object dot add function. I am calling here object dot add function. Now to access the method or function, we have to use the dot operator. We have to use the object name dot operator and the function or the method name. So here we are just declaring one class and you are writing something in that add function, and you are then accessing this add function with the help of the object name dot the method name. Method name is here add method. Okay, so here how we are inside the class definition, you are writing the method name. Similarly you can write it outside class definition. How you can do this outside class definition? Class example, then the, you are writing that the void add method, but only declaration part is done. Okay, so what is missing here? Here missing is when you are writing this only declaration, then here it should be a semicolon is there. Void add semicolon should be here. Okay, that is missing here. So void add and semicolon followed with, that means you are just declaring here but you are writing the definition outside of the class. So once the class is ended, you are writing the definition of the class method, that is the add method inside this. How you can write? Data type, name of the class, then scope resolution operator, and then the name of the method itself. So whenever you are writing the definition outside of the class, you need to use the scope resolution operator to access the method of the class. So you are accessing this with the help of scope resolution operator. This is the operator which can access the any member, any method of the class. Okay, so here you can write down whatever you want to write here the code accordingly for the add function. So just we are insisting here for how we can write down the method definition inside the class and outside the class. So one here one can just having the int main function, the same way we can call out the object name and the add method. There is no difference over here. Okay, so this is the main method calling for the object, and object is declared over here. Okay, so once the class object is declared, we are here. It is like it is now allocating the memory for this object in the memory allocation. Unless and until you allocate this object, declare this, the memory is going to have here creation of the memory for that object is done. Okay, so this is the thing where you are going to create a object. When you write the class, there is no memory allocation, but when you write the object or when you declare the object, then only the memory is created for the data members and the method of for that class. Okay, so the next is the messages. As we have seen the OOP paradigm, it consists of the different classes and the different objects along with the messages they are communicating with each other. Okay, so different objects can communicate with each other. Objects communicate with one another by sending and receiving information to each other. So, a message for an object, it is a request for the execution of the procedure or the method. We call it as a procedure or the method, and therefore will invoke a function in the receiving object that generates the desired result. For example, if suppose the employee dot salary, and in that you are having the member is the name of that particular name you are saying, and name you are passing as a data value from the method which is named as the salary. Salary is a method. So how we are passing this as a object of that class, particular class employee object is there, dot salary and the name of the data. So you are passing the object value through the method. You are passing the object value through the method. Okay. So next concept is data encapsulation. Data encapsulation is the very important concept of the OOP. So encapsulation is an object-oriented programming concept that binds together the data and the functions that can manipulate the data and that keeps both safe from the outside interference and misuse. So data encapsulation, this is the one important concept, or we can say encapsulation or the data hiding is the mechanism that associates the code. Okay, so encapsulation or data hiding is the mechanism that associates the code and the data that it manipulates into a single unit, that manipulates it into a single unit and keeps them safe from external interferences and the misuses. Okay, so the class feature of C++ implements the concept of encapsulation by providing the access specifiers. How it is providing? By using the access specifier. So what are this access specifier? It controls the actually the visibility status of the members of a class. Access specifiers controls the visibility status of the members of a class. So suppose what are the different types of access specifier in the languages? It can be a private, it can be a public, it can be a protected. So the members of a class declared private are accessible only within that particular class. Okay, that is only to the other members of the same class. The member declared are public are accessible anywhere from the within class or outside the class. So generally we don't make the our data members as a public. By default, it is a private, or you are having the writing habit of private only. So data members are private and the methods are public. You are generally writing the methods as a public and the data members as a private. This is the access specifier for the class. Whenever you write a class, your access specifier dealing is important. Why? Because you are doing the encapsulation property here, encapsulation point of view. One more access specifier is there, that is a protected access specifier, and we are going to discuss this later on. Okay, so the three access specifiers are there. One is the private, second is the public, and third is the protected. Now next concept is there, which is a data abstraction, or we can say the important concept in again OOP. Data abstraction refers to providing only essential information, providing only essential information to the outside world and hiding their background details. What is there actually? It is hiding from the outside world. So what are the background details? Everybody knows that software, we know that the only user interface, we don't know the background of that, which is the private, which is the primary key, we don't know. We only know the how we have to access that, and we have to type information and handle that. We don't know the actual background details of things. So that is what, to represent the needed information in program without presenting the details of the information. So data abstraction is one concept. Similarly, the data hiding is the another concept, which is a object oriented programming technique of hiding the internal object. So along with data abstraction and the data hiding, this is we in combination we are using this. So that is the data members. The data members we are keeping it private, so we are hiding this the information. Okay. So next is we have the data hiding concept fundamentals as well as the what is the abstraction, because we are dealing with this both in combination. So the data hiding is, it is the process that ensures the exclusive data access to the class members and provides the object integrity by preventing the unintended or the whatever the changes, intended changes. Then in abstraction, what happens? An OOP concept that hides the implementation details. Whatever the implementation detail, how it is implemented, whether it is using the friend class, whether it is not using the friend class, that is what implementation details. It is not showing that, only functionality is showing to the user. Okay, or whether it is using the polymorphism, whether it is using the inheritance, it is not showing to the outside user. Okay, then similarly here for the is represented on the providing the protecting data. In data hiding, focuses for the protecting data, and in abstraction focuses on hiding the complexity of the system. So how the your system is the complex, it is not showing to the user. Okay, it is the building matter of the abstraction. So for data hiding, it helps to secure the data, and for the abstraction, it helps to hide the implementation details, which is only displayed to the functionalities to the user, outside functionalities. It is not the in-depth functionality to the user. Okay, so this is the basics only for the our next is the simple program we can discuss here. Simple program illustrating the working of the objects and the class in the C++ language, as we are dealing with the C++ language. So just I have given the hash include, as you know, the IO stream first, that is required for the input output related classes. Then using the namespace standard, this is the next line. And next is the creation of the class. As I'm creating a class room, so the name of the class is room. Then I'm mentioning some variables in double, that is length, breadth, and height. Then I'm calculating area and calculating the volume, and I am doing this.
Your voice is breaking.
Hello, hello, am I audible?
Yes,
Yes,
ma'am.
yes.
Yes,
Okay.
ma'am.
Okay, so what we are doing here, we are just calculating the things using the variables, using length, breadth, and height. These are actually data types of double. We can use the double data type. We can have double means we can have the float data type. Okay, double. So we have the method which can access these variables. So methods is calculate area and another method is calculate volume. So we are writing the definition as well. That means we are writing the definition inside the class. That is the one way. And another way we can write down the definition outside the class as well. So classroom, this classroom is having the variables as well as the member functions. Member functions are calculate area and calculate volume, followed with the ending of the semicolon. This is the creation of the class. I have created the class. Okay. Then next, how to access this? We can access this by using the object, right? So I need to create the object. The name of the class is room, where the execution starts with the help of main method. So I have written the main method, int main method. Then I have created a object room1 of the class room. So the creation of object is done. Then I want to assign the values to the data members. So I can use that with the help of the object. Okay, unless and until you create the object, you cannot access the variables. So because how I can consider this room1 as an object dot, I can access the data member length, which is equal to, now I am assigning the values. Then similarly I am assigning for the breadth value and the height value. After that I am just, as these values will be passed over there, so I am using the cout function here, and the area of room is equal to, I am actually using the room1 as an object dot calculate area. I am calling over here, so it will calculate area using the equation of area. And then again next statement is cout volume of room, which will, I will again call here calculate volume method. I will call here calculate volume method. Now what is this endl? Endl is used to take the cursor to the next line. Okay, so this is what you are, if you run this program you will get the output, which is calculate area for this particular length, breadth, and height. Okay, you can see this. What is the equation? Equation is what it will return, length into breadth value for the calculate area,
Length into breadth value.
breadth, so it will multiply that and it will return where it will return, it will return here.
Next line.
No, this is a cascaded. So this is one will be here only. Area of room is equal to area of room. It will calculate over here.
Value.
Okay.
Length.
Length into breadth, area of room calculated here, and the value will put here. Area of room is equal to value will be putting here, and then it will take the next line because endl is afterwards. Okay. Okay. Hello.
Okay, ma'am.
Huh.
Okay, ma'am. Okay,
Next
okay,
is
ma'am.
volume of room. Now is equal to. This will write, okay, on the display device. It will write as it is volume of room is equal to. Now it will call the method calculate volume O here. Compiler will call it. Now when it will call, it goes to the definition. Now where is the definition? Definition is here. Okay, so now what it will return? Length multiplied by breadth multiplied by
Length into breadth into
into height. So now the calculated value will goes where it has called. Now here it has called. So answer will be kept here. Answer is here. After returning answer will be here because it is returning the value. So wherever it is called, it will return the value, and now it will put this value here, and then it goes to the next line. Why? End L is mentioned here, so it will goes to the next line here. All right, then it will return because int
Ma'am,
main
cursor
is
is not visible.
hello. The next line it will goes, then return 0 is there, so it will execute the return 0, and then it will complete because the next line it has the closing brace. So the task is over. Now it will conclude the giving the output area of room and the volume of the room. Okay, so this is what you are giving this, right?
Yeah, ma'am.
Okay, now I am just using the next PPT. I'm sharing next PPT.
Okay, ma'am.
Okay, so no, this one is the same. Is it visible to you?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
No, ma'am.
Yes, ma'am. Direct.
Visible, no?
Yes, ma'am.
Yes.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Okay, so the next concept, that is inheritance. One by one we are looking all the concept only. This is what overlook is going to give for all the concept. In depth we are learning this. Okay, so inheritance is a process in which one object acquires all the properties and behaviors of its parent object automatically, or parent class. In C++, the class which inherits the members of another class is called the derived class, and the class whose members are inherited is called as the base class. Okay, so what is that? The new class is called as derived class, and the old class is called as base class, where the properties are
Ma'am,
inherited.
inheritance slide.
Hello. So the derived class is also called as the child class, and the base class is also called as the parent class. Okay, so derived class is also called as the child class, and the base class is also called as the parent class, because it is a parent class from where we are going to inherit the properties towards the another class, and that another class is called the child class or the derived class. It is all the properties are inherited according to the specifier scope of that particular class. So one can see that there are the different types of inheritance. Different types of inheritance are the single inheritance, multiple inheritance, hybrid inheritance, multi-level inheritance, and the hierarchical inheritance. So these are the different types of inheritance for the our inheritance concept. One by one, we are going to see this in the next class when we start with the unit 2. Then there is a fundamental for this example is given inheritance, how we can do the inheritance. So the base class is given, class vehicle, and then the property for this or the members string brand that data is given, which is the value. Then the method is called here void honk, and similarly this class we can, this is a called as a base class, and another class we are writing the derived class. So for the derived class I can use the class car. This is a derived class, and I'm accessing the public in scope. The public is given, why all the features of this vehicle class can be publicly accessed. So this is a vehicle class, and I am just writing the car definition. In that I am writing the only one string, that is a model, and altros I am writing there. And then I am writing the main method. I can access now how I want to just declare the car object. I'm not giving the base class object, I'm giving the child class object. That is the car. My car is the child class. So I'm writing the object of car, my car, declaring it. After that, I am just declaring the method which is I can access through the parent class. My parent class is vehicle. So I am accessing the method of parent class honk, this method. So after that I can access my own member variable, that is for my derived class, that is a car, along with the model. So directly I can access this because I am already a object of my derived class. So this is what the example I can put here. Okay. Similarly, the inheritance, next is the polymorphism concept. So the world, this polymorphism is important concept for the OOP, and the word meaning of polymorphism means having many forms. So, in simple words, we can define polymorphism as the ability of a message to be displayed in more than one form. So, I can represent a form in many forms, displaying the thing, whatever I want to display, whether it is addition of two numbers. So, I can display in many forms. I can do the addition of integer, I can do the addition of double, I can do the addition of string also. So the definition is one, and I can represent it in many forms. So that is what the polymorphism feature. A person at the same time can have different characteristics. For example, like a man at the same time is a father, a husband, as an employee also. So it is like a characteristic. So the same person behave differently at different situation, which is called the polymorphism. This is a real-time example. It takes place when there is a hierarchy of classes and they are related by the inheritance as well. Okay, so this is what another important thing, polymorphism. All right, so there are again different types of polymorphism. So one is the compile time polymorphism, another is the runtime polymorphism. So compile time polymorphism are again divided into the method overriding and the operator overloading. And the runtime polymorphism comprises of the virtual functions. So these are the types of polymorphism. All right, these are the types of polymorphism. So One example is already discussed here. So class shape is given and the protected their variables width and height is there and shape is given. So likewise it is assigning this width is equal to value and height is equal to value. This is actually constructor constant. We are going to look this in detail. So I don't go in the depth. You just go through this example polymorphism, how it is accessing the polymorphism in different way. Okay, so this area, I can use this area function with respect to the shape class. This is what inherited from the shape class to the different rectangle class and triangle class. So I can use this concept of polymorphism and inheritance with in the combination. Okay, now we'll stop here.
सब दिखाई दिया पानी के पास